Good morning, students. Today I am going to explain about light emitting diodes. So what is light emitting diodes? We can call it as shortly LED. So a PN junction diode which emits light when the forward biased is known as the light emitting diode. So the emitted light may be visible or invisible. So the amount of light output is directly proportional to the forward current which is flow through the PN junction diode. So thus higher the forward current, higher is the light output, that is intensity. So the schematic symbol of the light emitting diode is shown in figure. Here the arrows pointing away from the diode symbol represents the light which is being transmitted away from the junction. Okay. Next, let us see the construction of LED. See, look at the figure. This figure shows the basic structure of light emitting diode. Here, N-type material, that is N-type layer, is grown on a P-type substrate here. So, by a diffusion process. Then a thin P-type layer is grown on the N-type layer. So the metal connection to the both the layers make anode and cathode terminals as indicated. Okay, so the light energy is released at this junction when the recombination of electron with holes takes place. So after passing through the P region, the light is emitted during the window provided at the top of the surface. So it will be interesting to know that, just a minute. So how the LED will works. So it will be interesting to know that when LED is forward biased, the electron and holes move towards the junction and the recombination takes place. Okay, so after recombination of electrons lying in the conduction band of the N region fall into the holes lying in the valence band of the P region. So the difference of energy between the conduction band and valence band is radiated in the form of light energy. So in ordinary diodes, the energy is radiated in the form of heat. So normal PN junction diode does not produce light, and also it will radiate the energy in the form of heat. So the semiconducting materials used for the manufacturing of LEDs are gallium phosphide and gallium arsenide phosphide, and also the silicon and germanium is not used for manufacturing the light emitting, that is in LEDs, because there are heat producing materials. Moreover, these materials are very poor in emitting light radiation. So the LEDs radiate light in different colors such as red, green, yellow, blue, orange, etc. Some of the LEDs emitted infrared also. So the color of the emitted light depends upon the type of semiconducting materials used in the LED. For example, the gallium arsenide emits infrared radiations. Gallium arsenide phosphide produces either red or yellow light. Similarly, gallium phosphide emits red or green light, and also gallium nitride produces blue light. Since so LEDs have a clear cases, there is normally no label on the cast to identify the leads. So the longer one is a positive terminal and the shorter one is a negative terminal. And we can classify the LEDs in three types. One is the leads may have different lengths when the scheme is used. The longer of the two leads is usually at the anode. And the second category is one of the leads may be flattened, and the flattened lead is usually as the anode. And the third category is one side of the case is flattened and the lead The lead closed to the flattened end is usually as the anode. So there is a large variety of light emitting diodes are available in the market. So they are all available in the different shapes and sizes, but the more commonly used LEDs are cylindrical in shape and the available in 1, 8, 2, 3, 5, 8 millimeter diameter sizes. And the low current LEDs are the then applications. What are the applications of LEDs? So the low current LEDs are useful in low power DC circuits, telecommunications and indicators, portable equipments and keyboard indicators. The super bright LEDs are suitable for applications, whereas normal LEDs are not bright enough. They so to restricted view angle. So the flashing of LEDs don't need any external series resistor, because they have but in the integrated circuits to give flashing effect. So special ICs are also available for driving LEDs. For example, IC BCT3215 device can drive up to 10 LEDs. It can supply 20 milliampere current to each LED. In other words, it has a total current capability of 200 milliamperes.